There we go. Okay, awesome. So let me just full screen this. There you go. So welcome to the Women in Computer Science Engineering Club, our general meeting on October 28th. So some club news is we have a new treasurer.
Hi, my name is Fiorella. My name is hard to say sometimes, so you can come up with any nicknames you come up with, it's fine.
All right, awesome. So some other news is we have a general meeting next week, which is October 28th. We're thinking about showing a Halloween movie, and so we'll be putting a poll soon in our Discord channel to vote on like which one do you guys want to watch. And then we also have our 3rd edition of our October newsletter available, thanks to Oz. It was emailed to you if you're on the email list, or we also post on Discord. So some upcoming events is the IEEE Women in Engineering Leadership Summit. It is October 29th at 8:15 a.m. to 4:30 p.m. It's hosted by IEEE, it's not hosted by us, but it's a great opportunity to listen to a whole bunch of different speakers, to hear about their experiences in the workforce, network, and things like that. I believe it's 100% online. And I think registration is free, so if it's something that you want to do, I just wanted to have it here to make you guys aware of it. So you guys on Zoom, any questions?
Can you hear me?
So I'm going to assume then you guys are good. Okay, so that means we can move on to today's workshop. It's going to be an intro to C++. And so what is C++? It is a cross-platform language that's used to create high-performance applications. It's an extension of the C language. It's basically the C language, but with classes. It's one of the world's most popular programming languages. And because it's C with classes, it is object-oriented, meaning that it gives us clear structure to our code and then allows our code to be reused. And then that will be for later. Okay, so with that, you're good. Yeah. I want to get into the actual workshop itself. Let's see here. Fortunately, I have stuff on the board. Okay, so it depends on what where you want to program if you want to be able to follow along. Otherwise, if you just want to watch, that's perfectly fine too. If you want, you can program on Linux, or you can also program on Windows. For me, I will be programming on Windows since I like to use Microsoft Visual Studio. But if you again want to use Linux, that's perfectly fine. If you don't have like an IDE, I recommend using like an online C++ compiler. Like, let me grab the link for one real quick. The only caveat is if you want to save your file, you have to log in, but it's still a really nice, easy use, free tool. It's not bad. Microsoft Visual Studio, yes, it is for free. At least if you're like a student using it. I think it's like Microsoft Visual Studio, like Community Edition, I think is the free edition. But you can just Google it and you should be able to find a download link. That's really great because it can do more than just C++. It can do a bunch of other languages too. Okay, so let me have that. I'm going to go into my project here. There's my phone. Okay, so whether you're doing this online, on Linux, or on some sort of other IDE, I'm going to start with just a blank page. And I am naming this one workshop.cpp. It really could be named anything, main.cpp, whatever you want. I just called it workshop.cpp. And then kind of one of the practices I like to do is always have the name of the file up top, because if you ever print this out, then you don't know what the file is. Give me one moment. Here's falling asleep. one moment.
Alyssa, can
All
you
right.
hear me?
So the first thing I want to do is set up a basic kind of shell for our program. So the first thing we do is do this pound sign, right, include, and in that I'm gonna have these little carrots and type in IO string. That's the first thing we're gonna include. I'll explain it soon. The next line that I'm gonna do is it's using namespace. We got a comment here. We cannot hear you, unfortunately. Let me see if I can fix that. Yeah, unfortunately I can't. Not 100% sure why. So I do have this sound. Let's see. Let's. You tried? Okay. Can you try it again? I tried to turn you guys up a bit.
So my question is, do you know what extensions we need for VS Code for the C++?
Oh, there we go.
There's a horrible.
Okay, darn. That could work though, as long as I'm quiet.
What?
Ask your question again, and then we'll just stay quiet. So
That's what I understand. It's easy.
Wait, hello?
I'm sorry. Okay, can you guys hear me again? Sorry, we're trying to figure this out. Okay, you can. Awesome. Can you guys try saying something? I'm going to mute myself so we don't get like this feedback, but I want to see if I can now hear you guys potentially.
Hello?
Hello?
Okay, awesome. Yeah, okay, we can hear you. It's just a little funky because whenever I talk, we need to make sure that we mute on our side, otherwise we get weird feedback. But we'll try our best. So let's see here. So it's a question about what extensions you need to download with Visual Studio. So there should be an extension for like general C++. Unfortunately, I'm not 100% sure where you would get it. It's been a while since I've re-downloaded Visual Studio.
on the installer, when you're downloading it, it gives you all these options. So as you're installing it, you can just click which codes that you want. You should be able to get Python or Java or C++ or any of those. That is for the regular Visual Studios. If you do get Visual Studios Code, that is an open source. It was made so that people with like Windows or Linux could use it, even though they've now allowed, like they made a version that Mac can use. But if you get Visual Studio's code, there's like a ton of extensions on your left-hand window, usually when you start it up. And then you can just type in what you want and get an extension from somewhere on the web.
Do you want us to wait for you till you are able to get Visual Studio up and running, or are we okay to continue? So just let us know, because I don't want to leave you guys behind. You're good? Okay, awesome. Oh, okay, you have VS Code. Okay, yeah. Go to the extension tabs, which I think is like kind of in the middle left, I think, of Visual Studio Code, or top left. And then type in, like, was it like just C++ compiler? And I believe there should be an extension. Actually, let me look it up because I don't have it on mine. So let me do that myself, actually. Go to my extensions. Let's see here. So it loads. C compiler. Oh, there we go. It's a compiler explorer. The C compiler. Do you happen to know?
So, you know, because Visual Studio's code is open source, that means anybody can add an extension to it. You know, that's one of the big differences from Visual Studio's code and Visual Studios. I would go with the Microsoft version, C/C++. It has like IntelliSense and you know, debugging and other stuff that you can do for it. It's built by the standards. So just type in on extensions on your left-hand bar, you know, all the little cubes at the bottom. Click on that. And then, yeah, if you were to just hit C++.
Should I just do C++ itself?
Yeah, if you just hit. Yeah, you'll see Microsoft right at the top.
This one?
Yeah. I mean, I trust them considering, you know, Visual Studio is there. So I think that's probably the best one to run.
Okay. Does it come with a compiler?
Don't think it does. Let me see if I can find that compiler. I believe, yeah, it's so if you go to Code Runner.
Just type in Code Runner?
Yeah.
This one?
Yeah. And so that's a run file. So that way you just have to push a button for all your stuff to be compiled, and you'll see at the top all the languages that it works for. And so you have, you know, for C, C++, Java, JavaScript, PHP, Python, Perl, Ruby, Go.
All this stuff.
Yeah,
Okay.
all this stuff. So if you install that one, it should just be a click away. That way you don't have to go through the work of setting everything up.
Okay. Do you want me to try it, or as I've never used it before, so do you want me to try using that?
Yeah, if you want.
Okay. At least so if we ever able to get work, then we can help others who aren't able to, or you know, if they're struggling getting it to work. So one moment. I'll just do this. So okay. I just gotta find it. There we go. Round. Okay. So is it this right here? I'm guessing. Run code. Okay. Well, let me see. On my end, I'm gonna start. It's okay then. I'll close you. Don't save. I'll try this here. Okay. So hopefully now we've got everything all up and running. Sorry for the delay. So there's a bit of experimental. We're going to see if we can get this to work. So the first thing to set up is I'm going to do the pound include, and then I'm going to type in IO stream. The next thing I'm going to do is type in using namespace and std for standard. And then I'll explain kind of what that is. It's kind of in a way kind of configuring our program. But in just a moment, I'll explain like what actually are they. So the next thing I'm going to do is I'm going to type in int main. I'm going to do open and close parentheses, and then open and close these like curly brackets. So that's kind of like the bare bones setting up the basics of your program. The first thing that I want us to do is practice some basic output and to also test this, this Visual Studio Code extension, just make sure it's working. So the first thing I'm going to do is I'm going to type in it's C and then out. 2 of these left little like carets. And then in that, I'm going to do double quotations on both sides and type in hi. After that, I'm going to do more of the double, like 2 carets to the left. And then I'm going to type in END and L, which stands for end line. Once I have that, there's only one thing I need to do to basically finish up this very simple program, is I have to be able to tell our program when to stop running. So I'm going to write return 0. And once it hits this line, our program is going to stop. So let me save it. And let's try this. It does not like it. What is not like about it? G++ not recognized. It's having it does not like that online. I'm not sure why. I couldn't install just a regular extensions. Sorry guys, it's a bit experimental. If not, if you guys can't get the Visual Studio Code or Visual Studio working, then feel free to use the was it the website that I posted? The online version, I'll repost it. So that's the easiest, quickest way to do it. So I'll post that again just in case. Yeah, because I'm having issues on my end. So I'm going to go back to what I normally use, my Visual Studio Code, if that's, no, sorry, my Visual Studio, not Visual Studio Code, if that's okay. Just so I can keep things going. No worries. Okay, thank you. Okay, there we go. So this is what we kind of are a very, very basic program. I'm going to run it. Depending on the editor that you're using, there might be just like a little like go button. For me, there's a shortcut. It's Control F5 on Visual Studio. And then just give it a moment. My laptop's not the fastest. There you go. And now the console pops up and then I can see what I typed in. I typed in hi. And so now it's outputting that to the console. So there you go. We just ran our first super simple basic program. And with that, I'm going to start explaining kind of like what's going on here. What are these things that we added? So the first thing I'll do is this here, this include IOStream. As I said earlier, it's kind of a way to configure our program. It's called a header, which is including some sort of library, which libraries are great because they come with a bunch of already pre-made functionalities. So that to do a lot of things that you want to do in programming, you don't have to do it 100% on your own, like by scratch. There's a lot of libraries that already have those functionalities made. Like for example, like a sort, like maybe you want to sort something from in ascending order. You don't have to do that manually. There is a library that has that function already pre-made. And so that's just what this is. It's a library called IOStream that helps us with input and output. The next line, this using namespace standard, it means we're using, as it kind of suggests, a namespace called standard. And so it means that for keywords like you see here, like this cout, this end line, and things like that, are all defined within this library IOStream. And so to be able to access those, we need to say that we're using this namespace so that basically when our programming is running and say it runs into cout, by default, it doesn't know what that is. But because we said we're using namespace standard, that points to our IOStream here. So it knows to look at our IOStream library to see, okay, what is cout supposed to do? And so that's why these two lines are kind of an initializing, setting up our program. Now the next bit is this int main. So technically this is what you call a function, which we will get into later, is the main function, as its name main. By default, when you run a C++ file, it's going to automatically run whatever is in that that main function. So for now, we're going to leave everything in that main function because when we run our file, we want exactly whatever is in here to run. So that was our first bit, is some basic output. Some stuff that I would like to also go over is this end line of what it is basically when you output something to the console, it doesn't automatically jump to the new line, like if you're like to press enter. But if you put this end line keyword, then it's going to automatically jump to the next line. So I'll show you an example. I'm writing another cout, maybe put like hello. So I'm going to keep my end lines there. I'm going to run it. And hopefully that you can see that my hi and my hello are on two different lines. Now say if I were to get rid of this first end line, I just had my semicolon, which the semicolon for C++ you always need to put at the end of a line so that the compiler knows this is all one thing, that's all one thing, otherwise it won't understand what you're trying to do. So I'm going to compile it again, but this time without that first end line. And now you can see hi and hello, they're all on the same line. But if you have a bunch of text, that's not necessarily, might not be what you want because it might be really hard to read. So that's what's nice about that end line keyword here, is it just bumps it to the next line. There's another kind of shortcut instead of doing the end line. You could do, it's a \n. It's called like I believe an escape character that does the same thing as end line. It's just another way to kick it to a new line. Again, if I compile it, give my computer a moment. Thinking about it. There you go. And then it kicked it to the new line. So that is some very basic output. The next topic that I want to cover are variables and data types. Before I move on though, I want to kind of label what we're doing. This first part is our basic output. So if you want to put a comment into any C++ program, you do this double /. And then when your program runs, it's just going to ignore that line because it's a comment. You don't want it to do anything with that line. It's just for readability's sake for the person to use, but the computer doesn't need it. So I'm going to name this part basic output. Oops. If I can spell. Okay. So that's our basic output. And the next I want to go over our variables and data types. So within programming, it's very handy to have containers that can hold data, and these are called variables. And there's many different types of data that programming languages, especially C++, can support. So I guess I could first go on like the different types of data that we have. We have integers, so which are like whole numbers. We have, they're called floats, but they're basically numbers with decimals, like 4.5 is considered a float. You might also see the word double as well if you're looking up floating point values. It's the same thing, it just means a number with a decimal. Just doubles allows for more spaces behind the decimal. It's essentially, I think, double the size of the float. That's why it's called a double. It just allows for more numbers behind the decimal here. The next data type is a string. So a string is always encapsulated in these double quotations. And a string could be anything, a bunch of numbers, letters, just a bunch of characters in general. So even something as random as this with my numbers, some symbols and stuff, that's a string. And then our next data type is called a character, which is encapsulated by single quotations, which is, as suggested its name, it's just a single character. And then we also have another data type called a Boolean. I'll type this here. That's how it's written, a Boolean, which is basically is just a true or false value. So true or false. So a true would be like a 1, and a false would be like a 0. So let's practice this along with some variables. Because if I just write 5, it's just alone. We don't have a container for it. We can't like reuse it anyway unless we write 5 again. So let's say we want to save that 5 into something. I want to use a variable. Let's say I want to call it number. I want to say it's equal to 5. It's holding 5. Within C++, you have to let it know what type of variable is this. In this case, we want our variable number to hold an integer. So I'm going to write keyword int. So now this is an integer variable named number that holds the integer 5. And I can output this. So I'm going to do my cout. I'm going to do my number and line. Let me move, I need to move my return 0. Make sure it's at the end of my main, otherwise it's not going to run the code, any code above it. Or below it, I'm sorry. Okay, so let me try running it. And we'll see that our number contains 5, and so oops, when we print it, it should output, because it should output 5. And also, what does it not like? Writing. Okay, why does it not like it? Let me try writing it again. Man. Okay, well, it's why does it not like me? Let's do efficient. Cannot open it. Okay, that's weird. All right, well, give me one moment. When in doubt, restart. I'll just make a new project. It's probably because I had to open a Visual Studio Code at the same time, so it didn't like me having it open in 2 different things. So let me just start with so it's gonna name it. Actually, it's comes up hot name. It's gonna be workshop. Solution name is gonna be workshop. Give it a moment to do its thing. Sorry about that, guys. It's my guess is it's because it is open in 2 different locations and it doesn't like when I do that. Oh. So let me just copy paste. There we go. Okay, let me try running it now. There we go. Okay. So you still see our hi and hello from earlier, but now you see our 5 there, which our 5 was being contained in this variable number, and now we output that to the console. So we're going to try a couple other ones. I'm going to try that float. I'm going to call it maybe num with decimal. And then I'm going to set it to me like 4.5. One thing here is when you are making variables, you can't have spaces. Otherwise, the compiler will see it as 2 different things. Like if I have like num with decimal, it's going to see that as 3 different things. So personally, when I make variables that have like multiple words in them, I put these little like underscores. Keep it all in one thing. So that's our float, aka our number with a decimal. We're now going to try a character, which you use the keyword char or char, or whatever you want to call it. I'm going to name it letter. And I want this character variable to hold the letter B. I'm going to use that single quotations. Next, I can have a string. I'm going to name it like a sentence. Equal to, I use my double quotations. I'm going to say this is a sentence. And so this whole line of characters here, that's my string. Then the last one I want to go over is a Boolean, which is keyword bool. I'm going to do TF for true or false. That's why I'm going to name my variable. And I'm going to set it to false. So to see what these values are, I'm just going to output them all. I'm going to put number. No, we already see number. I'm going to do num with decimal. And then I'm going to put space, so it's a little reader friendly. I'm going to output our letter, space, and then we're going to output our sentence, another space, and then I'm going to output our Boolean, which is that TF. And finally, just make things a little nice, end the line, so it'll go to the next line. So if we do anything more, we'll be ready to go on the next line. So before I forget, let me close this down. Okay. Now try running this so we can see all our variables in action. So there we go. We first printed out our number, which is this 5 here. Then we printed out our float, which we named it num with decimal. And that variable contained the float or floating point 4.5. Our character that we named letter holds B. Our string that we called sentence holds this is a sentence. And then our Boolean that we named TF, we set it to false, and so it outputs a 0. If I set it to true, then it'll output a 1. So that's some basic variables that you can use declaring them, but I also want to show like how can we use them. So maybe say we have a very short story. I'm going to put C out. I'm going to say there were once was a man named George. End line. Do another line. I'm going to say he was 70 years old. So we have a very short story here. We could hard code it in like this, but it might be kind of annoying. If like say you want to change the name George, say it's a really long story, you'd have to change every single instance of the name to whatever new name you wanted. Same if we like wanted to change the year. Every single time the year popped up in our story, we would have to change it. It'd be kind of a huge pain and really easy to miss something. So that's great where variables come in. So I'm going to do a string. I'm going to call it name. I'm just going to set it as, let's say a new name, let's say Alex. And then the next that I want to do, oops, I messed up there. Strings have to be in their double quotations. And then let's do an H. I'm going to make it an integer since it's a whole number. I'm going to name our integer variable H, and then I'm going to set it to 50. So now in my little cout here, I'm going to, there once was a man named, my little carrots, and then I'm going to insert my variable there, name. So it'll type out or output, there once was a man named, and then it'll output whatever is in our variable called name. And right now it's named Alex. We do the same with our year one. So we'll say he once was, we're going to insert our age there. And then put the rest years old. So now it'll output whatever we have name is and whatever we have age set to. So I'm going to run this real quick, show you how it works. I was thinking about it. There we go. Okay. So now we have our little story here. There once was a man named Alex. He was 50 years old. So say we're writing a story, but we don't like the name, so we change it. I don't know, maybe like to Bob. And he is 25 years old. We changed our variables, but we don't have to change the actual values itself in our little story here because it's using those variables. It's going to print out whatever is being contained within name and whatever is being contained within age. So let me run it again. And now you can see that's been changed. There once was a man named Bob, and he was 25 years old. So it's another great thing to use for variables, is for a lot of things so you don't have to hard code things in, and just they have so many different uses. So before I continue, we do have lots of throughout kind of console. So I'm going to comment out a large section of text. I'm going to do this / little star character. And at the end of where I want to comment, little star character, and then the / again. So now all of this is commented out, just so that we can move on and not have a bunch of our old outputs clogging up our console. So now that we messed with output and variables, I now want to mess with input. So let's do our little story again. Just gonna copy and paste if that's okay. The name and then the age. Let's say we don't set it to anything. We want to figure out what we want to give it something. We don't just want to hard code in the age and say it's 25. So we have a name, we have an age, but we need to set them to something. Say I want to be able to let the user set it to something. So you use the keyword cin. You use the little carrots, but this time they're to the right. And then I'm going to put name. So whatever the user types in, it's going to store whatever they type into our string name. What's kind of nice is to put make it user friendly, put a prompt to let the user know, please type something in. Otherwise, it'll just have like a blinking line and the user might not know that they're supposed to type something in. So I'll say, what is your name? And this time, I'm thinking about, I'll keep it on the same line. Let's have a space. So it's going to ask, what's your name? Our cin is going to let our user put in their name. The next, I'm going to ask them, what's your age? And then I'm going to cin again and say that whatever we input is going to be put into this integer variable called age. And we still have our little story here with our variables set up, but this time instead of hard coding our variables, we're going to ask the user for them. So let me try running my program here. So this is the first thing it's asked me, what is your name? So I'm going to put in Alyssa. What is your age? I'm going to put in 23, press enter. And now it's going to run our story here. There once was a man named Alyssa, and he was 23 years old. So that's some basic input of how you can get words and numbers or whatever you want from the user. All of it so that you can make your codes interactive, so that you don't have to hard code things in like names, so anyone can use it. But as simple as you just use a keyword cin. So moving on, let me comment this out. Here we go. So the next thing I want to go over is working with strings. Strings, again, if you remember, is any number of characters. Like we named one earlier, is called sentence. Any number of characters. It could be a single character if I want, but as long as it's within those double quotes, then it is a string. I can type wherever I want in here. There's a whole bunch of different things that you can do with strings. So in this case, I'm going to maybe say, instead of sentence, I'm going to name it phrase. And our phrase is going to contain the string, my pet is cute. So now phrase holds this, my pet is cute, and it is a string. So some things that we're going to do with it is we could find like the length of the string, how many characters are in it. So you don't have to use cout. You could just do the keyword here, which I'll be doing, it's phrase.length. You could just do that, but it's not going to output anything into the console. It's just going to be behind the scenes in the memory and stuff. So to be user friendly, I'm just going to output all of the operations that I'm going to do on this string. So just to let you know, the cout and then whatever operation we're going to do is not required. Technically, all you need is the operation alone, but just so we can see it, I'm going to put it with cout. So if I want to know the length of my phrase here, I just type in my variable phrase dot, and then is a function called length. And this is, if you remember going up here are like IOStream and our standard and stuff like that. This is an example of like a pre-built function, is we don't have to make our own thing that counts exactly how many characters on this. This length is a pre-built function, which is really great, that kind of does that functionality behind the scenes for us. I'm gonna end it with end line. I'm gonna run my program here. And there you go. So it output 14, meaning that we have 14 characters in our string here, which we do are 1, 2, 3, it includes spaces, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And so that's why it returned 14. The length of this phrase here is 14 characters. The next thing that we could do is you can also access individual characters within our string. Say maybe we want to just access that first M. So again, I'm just using cout just to make it user friendly so we can see what we're doing. To access like a single character within our string, I'm going to use the name of our string, which we call phrase. I'm going to use these brackets. I'm going to put in 0. And then end that with an end line. I'll compile this and show you what it does. There we go. So we still have the 14 from the length, but now we just have this M here. So we see we got this M from my. Now what the 0 is, it's called an index. And indexes in, I think almost all programming languages start at 0. Instead of starting at 1, you start at 0, then count up. So if you were to count the indexes of the string, it would go from 0, which is the M, 1, which is the Y, 2, 3, 4, all the way up to 13. So say maybe I wanted to get maybe this P from the pet. I'll do cout. I'll do my phrase. And then I want to do my pets or the P for it. So I'm going to say our M is at 0, Y is 1, space is 2, and that P is that third index. So I'm going to put in a 3. And then end line. And then I'm going to run it. And we'll see if that worked. There we go. Yep. And so we access the third index of that string, which holds that P. So that's how you can interact with very specific characters within our string. That's just writing them, but you can also write them, individual characters on a string that we already have. So maybe, I don't know, we want to put, instead of my, we want to put like by. So let's do phrase. I want to access that M, which the M is in that 0 index. It's the very first character in our string. And I'm going to set it to the character B, so that my will become by. And just so that we can see again what our phrase is, what it's doing, I'm just going to output a phrase. Compile it again. And there you go. Now we have a phrase. We replace the M with a B. So now it's by pet is cute. And so this is just some simple things. I think one thing I'd also like to show, it's kind of a cool thing that you can do, is you can find certain things in strings. Like you're maybe searching for a certain word or name or age or whatever you want to search for. How you do it is, again, I just want to output, so I'm going to miss you out. How you actually do it is I'm going to use our variable here called phrase. And I'm going to use a function called find. And so in these parentheses, they're called parameters. And it's basically giving this function here, find, information that it needs to know to do its thing. The first thing is, what are we looking for? So I'm going to put it's looking for pet. And then let's see here. The next parameter is we need to tell it where to start looking. We want it to start looking at the very beginning of our string. So we're going to say that index 0. So that we know we're starting with this M, the very beginning of our string. And we're going to keep going until the end of the string and then return where we found pet. Let me run and compile real quick. Okay, so now we have this new output, this 3, that's returning the index that we found the first letter and what we're trying to find this word. So we're finding pet, it returned the index where it first found this P. It's, if we look at our string here, M is 0, Y is 1, space is 2, and then a P for pet is in index 3. So it returns 3, saying that what we're looking for, pet, it begins at index 3. So it's kind of nice being able to use this function find if you're looking for, if a certain string or a certain word is already in a string. So that's mainly it for strings. There's a whole bunch of other things to do, but these are some kind of basic things. I now want to work on with numbers, because there's a whole bunch of things you do with numbers, just like you did with strings. And I'm going to just comment this out just so that it's not getting in the way of the new stuff we're doing. So you can do basic math and a whole bunch of other things too, but we're going to start with some basic math within C++. You could do stuff like 5 plus 5. You could subtract, things like that. Right now, though, it's just going to be us in the behind the scenes and storing in memory, but we won't be able to see it. So again, I'm just going to use the cout just so we can see what's going on. So first, we're going to do addition. We could just do like 10 plus 5. Go to our next line. We can also do subtraction. I'm going to do 10 minus 5. End our line. We can also do multiplication, 10 times, and it uses the little like star character for multiplication. Go to the next line, and then you can also do division. There's 10, and you use that / to symbolize division. And another thing that's very useful is it's called modulus, which is represented by this %. So it'd be 10 modulus 3. And basically what it does is it returns a remainder. So in this example, we have 10 modulus 3. 3 goes into 10 3 times. So you have 3, 6, 9. But then you have one remainder. You're at 9, but you have one more value that you need till you get to 10. So it's going to output 1. Our remainder is 1. There's a whole bunch of different things you could do with modulus, but that's kind of a basic introduction of what that is, just in case you're wondering, like, what the heck is this percentage? So I'm going to run it so we can see that our program here is doing math. So we see we first did addition, 10 plus 5 is 15, did subtraction, 10 minus 5 is 5, 10 times 5 is 50, 10 divided by 5 is 2, and then 10 modulus 3, there's a remainder of 1. So that's some just basic math. You can also do a bunch of math like all at once. If you remember, it follows like way back in your math classes, learning order of operations. I know some people remember it like as, please excuse my dear Aunt Sally. I always remember it as Pemdas, like that. It's parentheses, exponents, multiplication, division, addition, and subtraction. C++ follows the same conventions. So say maybe you have like 10 plus 2 times 4. C++ is going to follow that order of operations. So it's going to do the 2 times 4 first, and then add it to 10. So let's see that working. No, what did it do? I'm not sure what happened to it. Well, that was weird. Give me one moment. It like closed my file for some reason. That was really bizarre. What the heck? Why is, okay, this is weird. I ran it, but then it closed it. Okay, give me one moment. I'm just gonna reopen it. Having all types of troubles today with my laptop. All right, so let's see here. Let's hope that brings it back. Maybe. Maybe not. Oh my god, chat. Yes, it is. Yeah, it's one of those days. My goodness. Still not seeing it. So let me, not project solution. Hold on, let's see. So I tell it open a file. I'm not sure why it closed down my file. It's annoying. There we go. Okay, so I had it named something different. So we had it under workshop, main.tv. Yeah, this should be it. There we go. Okay, I don't know why it closed it. Okay, we're back. So I'm going to run it again. Let it compile. There we go. Okay. So the 15 through 1, that was our previous when we did all of our multiplication, addition, all that stuff. There 18 is that new, where we did the 10 plus 2 times 4. It did the 4 times 2 first, which lets you get 8, and then I added that 10, so you get 18. So if you know your order of operations from any math class you've taken, C++ will follow those exact same rules. C++ also has this nice, it's called incrementing it. So say you have, maybe I'm going to have a number. I'm just going to call it number, be very creative, and call it 10. And maybe I want to increase 10 just by 1. So I'm going to say our variable here that holds that 10 number. I'm going to do plus plus, which is going to increment this value by 1. So I'll now output our number to show that it's been incremented by 1. There you go. So we had 10, but now we've incremented by 1. Now we have 11. It's the same if you want to subtract. We can also do minus minus, and it'll subtract it by 1. Which might not seem that useful right now, but later on, incrementing just by 1 or decrementing by 1 is actually very useful. We could also kind of do a shorthand, like we could do number is equals number plus 10. So we could add 10 to whatever our number currently is, but that might be a little cumbersome to write out like this. So there's another way to do it, where you can just do number, and it's plus equals 10. So it's basically just shorthand for what we have right here. It's just we're going to be adding 10 to whatever is held in number. So let me comment that out and let's run it real quick. There we go. So we had our number. It was 10. We decremented it once, so now it's 9. Oh, and I forgot to output it. Sorry. We increased it by 10, but then I did not output it. So let me output it real quick. Again, why the output, the cout is so useful, just so it's user-friendly. We can put it to console and see what's going on. So we had 9, and then we did that number plus equals 10. We added 10 to what was ever held in number, which happened to be 9 at the time. And you can use the same shortcut for just about every operation, for division, multiplication, subtraction. It'd just be the same thing. It'd just be like times equals, divide equals, minus equals, stuff like that. I mean, if you want to, you could always do the long way. You could just do number equals number, like divided by 10 or multiplied by 10, whatever you want. But also, if you want to use the shortcut, also is kind of nice and quick and easy to use that as well. So some other ones, then we'll be done with numbers. We can move on to the more fun stuff, I guess. Is you can do some more complicated mathematical stuff, like find the power of something, rounding something, square root, and things like that. But C++ by itself, by default, doesn't have that capability unless you were to like manually like type in how you actually find like the square root of something. But we can include a library. It is called CMath. And this library here has a whole bunch of different math functions that we can use. So we don't have to manually like, let's see, like maybe you want to find like the power of something, like 3 to the power 3. You don't have to manually say 3 times 3 times 3. Our CMath here will let us use a function that just does it for us. So speaking of powers, I'm going to take the power. We want to put 3 to the 3. So we use this keyword pal for taking the power of something. 3 is our base, and we're going to take it to the power of 3. And then I'm putting that around our cout and our end line because I want to output it to console. run that real quick. And there you go, that's our 27. 3 cubed, or 3 to the third power, is 27. And so instead of having to do it all ourselves, we could just use this nice keyword power. Especially if you had like 3 to the 100, it'd be really cumbersome to have to put like, 3 times 3 times 3 times, all the way until you get 100 threes. They could just use a single line and now find 3 to the power of 100 if they wanted to. Another one is square root. So we use a keyword called sqrt for square root. And in the parentheses is what we want to find the square root of. In this case, I'm going to say we want to find the square root of 36. I'm going to output that to the console. Let me run real quick. So it still has my power in here. To demonstrate, it's really nice that 3 to the power 100 is a really big number. It's 5.1 something to the 10 to the 47. Again, trying to do that manually by your hand would be really annoying to have the 3 times 3 times 3 times 3, but it's nice you just have this little power function. In our square root, we took the square root of 36 and we got 6. So I want to do 2 more functions. We can also round by using the keyword round, and we put like 5.3. And it'll follow conventional rounding rules. So anything that is 0.0 to 0.4, it'll round down to the 0.0, or anything 0.5 and up is going to round it up by 1. So like 5.3, it should round it down to 5. And if we were to have like a 5.7, then it should round it to 6. In this case, I'm going to try 5.3, and it should round it down just to 5. Which we see right there, there's our 5. And one last mathematical operation I'd like to do, it's called Fmax, which it finds the maximum between 2 numbers. So say the 2 numbers I want to compare is 3 and 10, and I want it to return which one is the biggest number. So I'm going to run it. And so we get 10. The Fmax function that we use tells us that between 3 and 10, 10 is the biggest. So those are just some nice kind of capabilities of what you could do with math in C++. There's a whole bunch of other things, but those are some kind of basic ones. If you want to know more, you could just Google like C++ C math, and you'll be able to find lists of like all the crazy stuff that you can do with it. So the next section I want to go under is very useful. It's called arrays. Call that out. So we have variables, but they can only really hold one single item at a time. But what if we want to hold like lots of data? We don't want to have to make like 100 variables for 100 pieces of data. It'd be kind of cumbersome and not even good like on the backside for memory and things like that. So we use things called arrays to help us manage large amounts of data. So let's see here. When making arrays, you have to tell C++ what type of array it is. And what I mean by what type is it's what type of values are going to be held in that array. In this case, I want to store a bunch of integers. So I'm going to put int. I'm going to name my array something. I'm going to name it like, maybe I want to hold my favorite numbers. So I'm going to call it favorite numbers. And how you tell C++ that is an array is you do these brackets here. That tells C++ that favorite numbers is an array, and specifically it's an array that holds integers. But now I have to fill it with something. So you do equals, and you do your curly braces to fill it with something. So I'm going to say my favorite numbers are like 3, 27, like 33, and 40. So now our favorite numbers here is holding all of these values. Really useful, again, to hold large amounts of data. So we have all that data under one name. We also may, like, say you don't know what you're going to put in there quite yet. You know you're going to put numbers, but you don't have anything to put it quite yet. So you could declare an empty array. I'll just put fav num. maybe I know I'm gonna put like 50 numbers in it. But then I just leave it blank. You can also do that with arrays. That it'll still see it as a valid array, it'll just be empty, but you have spot for 50 items. So just in case you don't, like if you don't know your data, but you know there's gonna be data, you can make an empty array and then fill it later. So to access certain parts of this array, we can use that indexing that you saw earlier when accessing different characters for strings. So I'm gonna do my cout, my little 2 left carets. I'm gonna access our favorite numbers array. I got my little brackets here, and say I wanna get our first number, that 3. With C++, and as far as I know, pretty much every other languages, index starts at 0. So 3 is in position 0, 27 is position 1, 33 in 2, 40 in 3. So if we want 3, we have to access position 0. And then end line. So I'm going to compile that and see if we are able to get that 3. Which we do. We access the first element of that array, which happened to be 3, and then we output that to console. So that's just accessing values within our array. But say we want to set something. So maybe I want to replace that 3. Like maybe it's no longer a favorite number. So I'm going to call my array again right here, favorite numbers. I'm going to say that it's index 0, aka the first item in this array. It's going to be now equal to 5. And so I'm just going to again print out whatever is in that first index of that array. And we should see it was 3, but then it should be changed to 5. Which we see it was 3, but then that's no longer a favorite number. And so I want to change it to 5 instead. And now we see 5 is in that first spot. So that is both accessing items in an array and also replacing items in an array. So the next part that I want to go over are functions. Another extremely useful and important topic within really any programming language. So functions are basically like a collection of code that performs some specific task. What we've been doing so far is this main here. This has been a function. It's just a default reserved function for C++ that lets the program know we're going to run whatever segment of code is within that function, but we can make our own and do whatever we want in those functions. So let's see, for example, maybe we want a function that when you call it, all it does is it says hi. So I'm going to name this function say hi, open close parentheses, and then my semicolon. Right now it's throwing me an error because it doesn't know what say hi is. We have to declare our function and tell it to do stuff basically. So I'm going to go above my int main. In this case, functions always return something, or they can return nothing, but you have to tell it if it's going to return an integer, if it's going to return a string, or if you want it to return nothing. This case, I just wanted to output to the console, so I don't want to return any values. I'm just going to put void. So it's going to just do its thing. And once it goes, we run back into main, it's not going to like return a value or anything. It's just going to do its thing. So I'm going to void. Our function was say hi. We have no parameters, which I'll be going into more depth what I mean by parameters. And our open and closed curly braces. So this is an empty function. It doesn't return anything because of this void keyword. And we named it say hi. So now we have to populate this function with code so that once we run the function, it's going to do something. I'm going to tell it whenever we run this function, we're going to say hi. So this is it. This is our chunk of code within our function. And so in our main here, we're calling this function. We just call it by the name. You just write down the exact function name that you want to call. So when I execute my code here, it first ran the main, and it ran into my calling function here, my say hi. It then jumps to my function up here, then executes whatever code is in it. And what this code was is it just said hi. It output hi to the console. That is a very, very basic kind of bare bones function. I want to show one more, a little more, not advanced, but a little more fancy example. Maybe we want to have a function that specifically handles multiplication. So I'm going to name it multiply. And we're eventually going to pass in values to it. So up here, I'm going to say our multiplication function here, it's going to return an integer. So it's going to do some math. And the value that it's going to find is going to be an integer and then send that back to our main function. So I'm going to say int, and then I name this function multiply. And here's that thing where I keep calling them parameters. It's basically just values that you're going to pass to this function. You're giving it data so that it can do something with it and then return it back to our main function. In C++, you have to say what those parameters are, like their data types, and then you have to give it a name. So in this case, I want to multiply two integers. So our first parameter is I'm passing in a number. It's an integer, and I'm going to name it num1. That's the first piece of data we're passing to this function. The next is I want to do another integer. I'm going to name it num2. And so now within our multiply function here, we're going to give it two integers, num1 and num2. And then within this function now, I have to write something, make it do something, so this is the code. So I need a variable to contain our answer. I'm going to put like int answer. It's going to contain our num1 times our num2. So this integer container here called answer, it's going to hold the product of our two numbers. And then we want to use this function to return a value to our main. So instead of basically having to write this in one function, our main, we can kind of spread it out and kind of split up, like you could say, the work of it, make things a little bit nicer. So we have a whole function that all it does is multiply. We can call it within main, and then it'll return our answer. To do that, though, I have to use this keyword return. And I'm going to return specifically whatever is being held in answer. So it's going to return our product here between num1 and num2. Back here, I am not quite done. I have to give it numbers, and we're passing in two values, num1 and num2. Maybe I say I want to multiply 3 and I want to multiply 4. So I can pass in 3 and I can pass in 4. But our multiply function returns something, so we have to have a container that's going to hold whatever its result is. So int, I'm going to put like answer, but like maybe ANSW. It's going to be equal to whatever our multiply finds. So it's going to multiply 3 and 4. It's going to find the product. It's going to return that to main, and then we're going to store it in answer. So just to show you that this works, I'm just going to output what our answer is. We'll run it, and then you can see that our little function here should handle the multiplication. There we go. So we still have our say hi function, it's still there. But we see our multiplication function worked. It took in 3, it took in 4, it multiplied them together, it got 12, and then passed it back into our main function, stored it within our answer variable here, and then we output that answer to the console. So it's a little fancier example of how you can use functions that they can return values. It's just a really great way to kind of organize your code so that you don't have everything within one big function. It can get not very user friendly, get really long and cumbersome. So it's kind of nice to basically split up kind of the work within your code into different functions. All within still you have a main function that it's going to run by default, but then that main function can call other functions to help it compute stuff, answer stuff, put stuff to the console, stuff like that. So that is functions. I write down its functions. We'll comment this out, so we're going to move on to our next topic, which are if-else statements. So we say if Well, actually, I'm going to just do if statements first, then we'll get into the else. If statements. So what if statements do is they allow our program to respond to different situations. I'll do an example. Maybe we have a Boolean and we want to tell if someone is female or if they're not. So I'm going to name this Boolean is female. I'm going to set it to false originally. Actually, no, I'll put it to true. So by default, we are female. That's just all this Boolean is doing. It's holding a true or false value. And we're containing that within a variable called is female. Got a message. Let's see here. Oh, you have class. Okay, awesome. Well, thank you so much for stopping by. Hope you have a good rest of your day as well. So let's see here. Maybe if you have someone that is female, you want your code to do something specific. So you use a keyword if, and then in your parentheses, you have your condition. So I want to say if someone is female, I can just put is female. So if what's in this parentheses is true, then what's in these curly braces here is going to run. In this case, is female is true. So whatever I put within this statement, that is going to run. So I'm going to put cout, you are female. And let me run it. It should output you are female because is female is true. So let's see that right here. There we go. Our is female is true. So it output you are female. But what if female is not true? What if I said it's a false? Oops. Now what's in this if statement should not run. Because this is female now, it is not true, it's false. So this should not run. So let me show that. We didn't output anything. They didn't do anything because the only thing our code did was it's supposed to output you are female if you are female. Well, is female is false. So we don't do what this if statement says. We also have kind of a companion to if called else. So maybe we want to do something is if you're not female, then we want it to do something. Since we already have something that it does when you are female. So if you are female, it's going to output you are female. Else, if that's not true, if you are not female, we're going to say you are not female. So I'll keep is female false. And in this case, because is female is not true, it should go to this else statement. And it should print that you are not female. And there we go. Is female was false. So we did not go into our if statement because is female is false. And so instead we went into our else statement and it printed out you are not female. So let's say again that is female is true. That this time now it should say you are female because is female is true. And it should not output you are not female because this if statement is true. So let's see that real quick. There you go, you are female. So because now female is true, we ran what's in this if case or if statement, but we did not do what's in this else. So that's just our if statements with like Boolean values are true or false, but you can also do comparisons. So maybe, I don't know, maybe you want to compare like numbers or something. Actually, no, before we do numbers, let's do, like maybe you want to test multiple things at once. So we have is female, but what if we have like also like is tall? Originally, I'm going to put it as tall. You're female, that's true, but you're not tall. I can have if you are female, so is female. So if that's true, and which you use these double ampersands, and is tall, then we're going to do something. But both of these conditions have to hold true before we run what's in this little block of code here. In this case, I'm going to say you are female and tall. Which we can try this. Right now, female is true, but our is tall is false, so it shouldn't run this block of code. And actually for now, I'm going to comment out what we did have so it's not distracting us. So I'm gonna run our code. And again, it didn't do anything because both conditions were not met. We are female, but we're not tall. But say now I'm gonna change is tall to true. So now we are tall and we're female. And I'll try running it again. And there you go. Now both conditions are true. I am female and I am tall. So it does what this if statement says to do. It outputs you are female and tall. You could also do a bunch of other things. You can say like or, which is these two bars. So maybe I'll put like tall is to false again. So I'm female, but I'm not tall. This if statement here, like what's in here, is going to run if I'm female or if I'm tall, if either condition is true. So let's see, it should run because I am female, but I am not tall. I'd have to change my text because it doesn't make sense with what I have right now, but it ran because one of these conditions was true. I was female, but I'm not tall. But that's okay that I'm not tall because at least one condition was true. And you could do any combination. You could have like a bunch of ors and ands. It's whatever you need it to do. But that's the basics. So now that we have kind of our true and false, ands, ors, you can also do comparison with like greater than, less than, equal to, things like that. So I'm going to do num1 is equal to me like 5. Num2 is equal to like 10. Again, I'm going to just clump this out just so it's not in the way. So maybe we have something along the lines of, we want to do something if num1 is less than num2. So I'm going to do my if. I'm going to say if 5 is less than 10. So if that condition holds true, we're going to do something. In this case, I'm going to just do cout num1 is less than num2. I'm going to output it, and it should run that block of code because 5 is less than 10, which it is. Num1 is less than num2. You could do a whole bunch of operations. So you could do less than, you can less than or equal to, you could do greater than, you can do greater than or equal to, you can say, is it equal to, like exactly equal to 10, things like that. In this case, I'm going to leave it as 5 is less than 10. I can also do, maybe like I have more conditions. I want to say else if, oops. Let's see. I've just realized I hard coded this in. This was supposed to be num1, sorry. And this was supposed to be num2. Here we go. Else if, maybe you want to say if num1 is equal to num2, then we want our code to do something. So I'm going to say cout num1, oops, bring in my parentheses there. Num1 is the same as num2. I'm going to run it. We should still get the num1 is less than number2 because 5 is less than 10, but they are not equal, so it's not going to do this else if. Let's say now our two numbers are equal. They're 5 and 5. I'm going to run our code again. And now that else if ran, because our number1 and our number2 are equal, this is now true, so it's going to run this block of code. And that's kind of the basic fundamentals of if, else, whole bunch of things that you can do it, comparisons, ands, ors, nots, even if you wanted to, comparisons greater than, equal to, all that stuff. All right, so the next thing I'd like to go over, I know we're starting to run out of time. There's a couple things to go over. Is a concept called switch statements. So maybe you have like a whole bunch of conditions. You have if this, then you do that. If this, then you do that. If this, then you do that. You could do a bunch of if else, or if else if, and it could get really cumbersome. So you can use a thing called a switch statement, which is essentially a bunch of like else if else ifs and stuff like that together, just kind of at a little more user-friendly way to read it. So let's say here, I'm gonna have something that we give it a number and it's gonna return the day of the week. So I'm gonna have our day number. It's an integer and it's gonna hold whatever day of the week we wanna look up. I'm going to ask the user, type in a number for the day. And I'm asking them 1 through 7. So Monday through Sunday. And then I want to ask them, what's the number? I'm going to put it within day num. Then using that, we want to convert that number to the day of the week. So in this case, to kind of go back to review what we've done, I'm going to use a function. I'm going to call it day of week. And what we want to pass to it is its day number. And what it's going to do is using this day number, it's going to find its equivalent as the name and then return that. So I'm going to pass in day number. I want to output this though, so we know what it's doing. So I'm going to just put this within a cout. And it's still giving me an error because it doesn't know what days of week is, or day of week, sorry. So we have to go up and we're going to make my function above my main function. So here it's going to return a string because we're going to return Monday, Tuesday, Wednesday, Thursday. We're going to do a bunch of characters, so we're going to return a string. Therefore, it's a string function. I named it day of week. Let's see here. Let me look up something real quick. Sorry. Where did I put my function? There it is. Okay. So that's our function name. It's a string function. So we're going to return a string. We're passing in a number. So I'm just going to name it number. We're letting it know that what we're passing in is an integer, and I'm calling it number. Which this is just our day number that we asked the user for. So I'm going to have a string that's going to hold what day it is. I'm just going to call it day. So this is an empty string. It's just a container that we're calling day that's going to hold the day that we're going to find based on this number. So for a switch case, you use the keyword switch. And in the parentheses, you do basically what you like. I think it was that the exact word. You pass in like whatever value that you want to think of exactly how to word this. So depending on whatever the value you have in this parentheses, your switch statement is going to do something. So we want it to do something based on what the day is. So we're going to pass in day. And so depending on this day, we're going to do something. We're going to have our first case, which is 1. Oh, I'm sorry, not day. This is our number. So depending on what number we pass in, we're going to do something. Our first case is, say we pass in a 1. The user puts in number 1. And if they pass in number 1, then that means our day is equal to Monday. And at the end of each case, for switch case, you have to use a keyword called break. So that's our first case. If the user types in 1, what if they type in 2? So our case 2, that means it is Tuesday. Give a break. And it's just going to be a bunch of these cases. Case 3, if they give us a 3, then that means it is Wednesday. Don't forget a break. Case 4, meaning it's Thursday. Sorry. I can't program here apparently. Break. And I hope it's okay if I stop there because it's a little bit tedious, but you get the idea. You'll go through Monday, Tuesday, Wednesday, Thursday. Case 5 would be Friday, case 6 would be Saturday, and case 7 would be Sunday. But for switch cases, you should always give it a default. Because say we don't give it anything between, in this case, 1 through 4. We don't give it that. It needs to know what to do if we don't give it any of these cases. So use the keyword default. And then you just type whatever you want it to do by default, basically. If you put anything other than a 1, a 2, a 3, or a 4. So I'm going to just have it output, it is a day. That's all it's going to do. So this all here is our switch statement. Again, depending on what our number is, it's going to do one of these cases. Like if it's 1, then our day is Monday. If it's 2, day is Tuesday, so on and so forth. So now we want to return what our day is. So passing in our number, it's going to find whatever the corresponding day is, and then it's going to return that string, that Monday, Tuesday, Wednesday, or whatever. So back to here. So here I'm calling my function. And then I'm just going to be outputting it to our console. And again, I hope it's okay. I'm just going to comment out what we did before, just so that it doesn't get in the way. Okay, try running our program. So it's asking us, type in a number for the day. I'm saying maybe like I want Monday. So I'm gonna put 1 and it returns Monday. We do it again. In this case, I put in a 2. It should do Tuesday. Oh no, what did I just do? Oh no, I pressed the wrong button. Ah, okay, hold on. Open file. There we go. I have fat fingers apparently. Okay. So now let's say maybe we give it something other than the 1 through 4. We give it like 56. It just does that default statement, which we told it to just say it is the day. And that's the basic of switch statements. It's basically a bunch of if else, all that stuff, but just a nicer, more user-friendly way to write it. Right. I think I'm going to do 2 more topics. I know it's already almost 2:40. So bear with me, we're almost there. Okay. So the next 2 topics I'm going to go into are called loops, which are extremely useful, used for so many different things. The first type of loop that I want to go over are while loops. Okay, just before I forget, comment out our switch stuff so it doesn't get in the way. And so how while loops work is it's going to do something within that chunk of code until some condition becomes untrue. So I'm going to maybe, as an example, have an integer. I'm going to call it index, and it's going to be equal to 1. So I just have a variable index that holds the value 1. To make a while loop, you use the keyword while. And I want this loop to run while our index here is less than or equal to 2. And so I'm just going to output what our index is. There you go. So let me try running this. Oh, wait, hold on. I almost made a big mistake. Okay, actually, I'll show you it. So maybe you're making your loop, think, okay, yeah, I got everything done. It's gonna go from 1 up until it's equal to 2. It's gonna output our index. So let's see what happens when I run it. Just give it one moment. There you go. You just see 1, 1, 1, 1, 1, and you just see it's the constant's getting longer and longer and longer. It just keeps outputting 1. So what I did here by accident is I made an infinite loop. So it's one thing you have to be careful of while loops is if you set it up wrong, it might just keep going and going. And this statement in the while loop, it'll never become true. So it's just going to constantly run this. So that's just one thing to kind of keep in mind. To prevent that, I forgot to increment our index. So I'm going to increment it by 1. So it's going to start as 1. It's going to output that value, and then it's going to increase it to 2. Our index here, 2, is still less than or equal to 2, so it's going to run again. Oh yeah, luckily my laptop didn't freeze. Yeah, if it's anything more complex, it probably would, but thankfully a single number, it's all good. So let's try this. Now that I make sure we don't have an infinite loop here, it's going to increment our index. By each loop, I output the index. So the first loop, it output a 1, then it was incremented to 2. The second loop, our index was still less than or equal to 2. So our loop ran again, and it output 2 because our index was 2. And basically do the same thing. If I wanted to, I could do like, I don't know, to 10 or something like that. It's really up to you what you're trying to do. You can set whatever condition you want that your while loop is going to do something until that condition is not true anymore. Which now we have here, it started at 1, and it kept looping and looping and looping and looping until our index, it prints out 10, then it was incremented to 11, and 11 is no longer less than or equal to 10. So our while loop stopped. That's kind of the basics of it. You have kind of its opposite in a way. It's called a do while, which very cleverly, the keywords are do. And after that do, while. So the way that like they're kind of the same, but kind of not at the same time is it is a loop still, but the while loop checks for a condition first and then runs the code. Do whiles, it'll run the code first and then check a condition. It's basically just essentially the opposite. So in this case, maybe I'm going to set our index back to 1. And we're just going to do the same thing. We're going to output that index. We're increment its value by 1. And we want to do as long as our index is less than or equal to 10. And need to not forget to put my little semicolon there. So let me real quick just put a C out just to separate our 2 while loops here. Do while. Okay. Let me run it. There we go. And so they're basically doing the exact same thing. It's just a kind of a different order that they're doing it. And it's again, it's kind of subtle, but in certain cases, maybe you want the code to run before it checks as a comparison. Well, you can do that with the do while. Meanwhile, with the while, it'll check the comparison first and then run the code. But if the comparison is not true, then this is never going to run. But say you want it to run at least once, we'll use a do while. It'll run once and then check the comparison. But in this case, I just have it's doing the same thing. You start at index 1 and it's going to loop while that index is less than or equal to 10, and then output that index at each loop. So that's it. That's basically the fundamentals of while loops. I have one more type of loop that I want to do. Also really important, called for loops. I'm going to comment our while loop stuff codes so it doesn't get in the way. So next concepts are for loops. You can kind of think of them as a while loop, but we can constrain it a bit more. It also kind of allows us to like more easily keep track of how many times we're actually are going to loop. So for loops, you use the keyword for. You have to tell it when to start. So I'm going to say integer is equal to 0. That's our starting point. We're going to go as long as our I there. Oops, sorry, I forgot to put I int, and then naming it I is equal to 0. That's our starting point. And for as long as the I is less than 5, then whatever in this for loop is going to run. The third case, though, is I have to do something to that I so we don't have that infinite loop. In this case, I'm going to increment it. So our I starts at 0. It's going to run this loop, and then it's going to increment it. After it increments it, it's going to see, is I still less than 5? At this point, I will be 1. It is less than 5, so it's going to do the loop again. Then increment, I is 2. Then compare, is I less than 5? And I'll keep doing that until I is no longer less than 5. So let's see, I'll have another, I don't know what I want to do. I can just output what our I is, our cout, and then I'm just going to say our index. We're just going to output whatever our I is. Let me run that real quick. And there we go. So our I starts at 1. So our loop a loop runs. It outputs what our I is. It's currently 0. We're done in we ran our loop. It goes back to up here, increments our 1. So our I, increments our index I. Now it becomes 1. It is still less than 5. So we're gonna go into the loop again. That's why it now inputs 1. It's going to keep doing that until our I is no longer less than 5. So does it 0, 1, 2, 3, was it? Sorry, 1, 2, 3, 4, 5 total times. That's a very, very basic for loop, but again, can be used for so many things, just like a while loop is. You can put like dynamic variables in here. You don't have to put just 5. You put me like you want it to go for the length of something or whatever you want. You could do so many different things with it. This is just the bare bones of how to use it, and it's up to you how you want to use it. The last thing I want to do is go back to my array. I'm going to name it nums. It's an integer array. And I'm going to fill it with 1, 2, 3, 4, 5. Right now, the only way we saw how to output values is by accessing them like one at a time, like nums 0 to access the 1. But say if we want to output all of these, you can use a for loop to do that. So I'm going to put 4. We're going to start at 0. So int is equal to 0. We're going to go until this I is less than 5. The reason it's 5 is because of indexing again. For our array, 1 is at 0. 2 is at 1, 3 is at 2, 4 is at 3, and 5 is at index 4. So we're going to go up to index 4, but as soon as our index becomes 5, well, 5 is no longer less than 5, so we're not going to output the next value. And then each loop, we just want to increment our I. So all we're doing here is output whatever value is held at that current I value. So again, I starting at 0, and it's going to go from 1, 2, 3, all the way up to 4, and output whatever is in that index. So let's see, let me run the program. Okay, why is it being weird? Let me try that again. There we go. Okay. So the index, that's from our first for loop, but the second one, oops, there we go. Our 1, 2, 3, 4, 5, that is us accessing our number array here with our for loop. Every single loop, we're going to access one value within that array, and each loop, we're going to be incrementing whatever we're going to be accessing by 1. So first, we're going to do whatever in index 0, then whatever in index 1, then whatever is in index 2, so on and so forth. And that's kind of the basics of it. It's, again, so many different things you can use for loops. This is just another example. Maybe you want to go through an array and you want to do something to each value, or you just want to input, or sorry, output each value. You can use a for loop to do that. So I think I'm going to stop there because I know it's pretty much just about 2:50. So it's been a long session, but thank you guys so much for watching. Thank you for dealing with us, especially with our technical difficulties, but I'm glad we're able to get everything to work. So thank you guys so much.